Yes, go ahead. Speak. Yeah, tell me.
Yeah, Tarun. In the last class, I didn't attend. I just watched the recording.
Okay.
Uh, I have a doubt. You talked about sticky session, right?
Yeah.
I didn't really understand the use case where we need a stateful application server.
Okay.
You told some example of like Amazon, where we have got when we add an items, so it depends upon the previous and all those things, right? But that will be the data will be stored in the database, not in the application server, right? I didn't understand the use case where we need a sticky session.
Okay. Yeah. So in case there is a data which is stored not in the database, see, a lot of applications earlier used to use files. Yes, so it could be anything in the local storage of the application server. Could be files. So if assume there is an application which is storing information in the file of an application server, then it is a stateful application because it is relying on the state information in the file. And other applications won't have access to it. Or it could be memory also. Memory could also be there. Local cache could also be there, where some application storing some information which is related to the user, and this makes it a stateful application.
Yeah, but it has tight coupling, right? If you store the data in the database, that is like if that is if that is there, so why one should store something in the application server?
Yes,
So,
we should not store in the application server. We should store in the database, and application should be stateless. This is the first fundamental principle. Very less frequent use cases are there. We'll cover that. Some use cases where sticky sessions are helpful, we'll cover that. I gave one example of UPI. UPI is an example where you have a sticky session.
could you repeat that use case?
UPI. UPI, you do the payment, online payment nowadays with UPI. Yes. Like Paytm, GPay, Google Pay, Phone Pay. When we'll cover the architecture of UPI, then we'll discuss about sticky sessions more.
Sure. Yeah.
Right. So I'm purposely just introducing the concepts, terms, but yes, what you should understand is what is a stateless.
Got
clear?
it. Yeah.
Is that clear? Is what is stateless application? Because
clear.
that's what you should understand. Yes.
Yeah, clear. And one more doubt regarding when you are doing that, you added load balancer and active load balancer is there, passive load balancer is there. And actually, I worked at Amazon during the peak days. They told me to scale the load balancers. So what they told that, like, what if the traffic is so much such that load balancer cannot handle? You told it can handle 1 million transactions, but they told me to partition that into 2 load balancers and get 2 IP address. And they told me to do some OA record and all those things. So I didn't understand, like I did something which is there on the doc, but I didn't understand what I did.
Yes. Okay. So yeah, so no, don't go by exact numbers. Again, there are many load balancers available. There are software load balancers, there are hardware load balancers. So you can take some assumption like this is the number of transactions a load balancer can handle. But yes, in general, I will say load balancer only does the routing of the traffic to the server which is available. So it does very little work. Since the work is very little, it is running lightweight process. It can handle a large volume of request, right?
Yeah.
That is what you should understand. Load balancer has to be very simple. It should not be doing too much of calculations or doing a lot of processing of data. It is just required for routing the request to the server, which is, or it's required for distributing the load uniformly across all the available servers.
Yes.
So it should be doing things very fast and it should be scalable.
Yeah. So they gave a cutoff like 4 GB data per second. The load balancer is processing 4 GB, more than 4 GB data per second. We need to scale. So our service is close to that. So they asked me to scale the load balancer as well. So maybe what I am
again, no, I need to understand this in more detail. Sure. So here maybe we can have this discussion after the session, where I will ask you what exactly was the requirement, and then we can discuss that. Yes, park this question to the end of this session.
Sure.
Right, but yes, I am just introducing right now the concept of load balancer.
Okay.
Right, so you should just understand that load balancer is a component which is used to balance or distribute the load across multiple servers.
Sure.
Right, so I see a query from Ramesh about what is a software load balancer and what is a hardware load balancer. Software load balancer is a load balancer which is an application which you have installed. An example of software load balancer is Nginx. Right. Let me give you the spelling. Yes, Nginx. This is, you can go to this website also, you search Google. You will know, you can install it in your laptop also, Nginx. It's a kind of a very lightweight software. It can do load balancing. Now, what is hardware load balancer? Hardware load balancers are the specialized hardware where you don't have to install any software. It is hardwired. The various features of load balancers are hardwired in the specialized hardware which you purchase. So these load balancers are you purchase and you have to have a device. So these are dedicated device which is for load balancing. They are very expensive, but yes, definitely they will be very high performing than software load balancer because there is no software running. Everything is circuit. Yes, programmed as per the circuit or IC chip in the load balancer. So these are hardware devices which you purchase as a load balancer, and then you can it can take heavy traffic, and it is very high performing devices. They are very expensive also. One example of hardware load balancer is F5 load balancer. This is the name of the load balancer. It's a company is BMC, and they have this load balancer which is called F5. You can search and you can also learn about these load balancers. So yes. Now let's today discuss about databases. So today I want to discuss about databases. We'll be covering various concepts around databases because yes, we did some simple applications. We did tiny URL. And what else we did? We did a website, Delicious, right? Bookmarking website. We were doing until now all the applications which was just having 1 or 2 tables. But yes, if we want to build more complex applications, you will need a lot of databases also. So we'll be covering about today relational databases and various concepts associated to it. Right? Shall I proceed or any other doubts you have? Right, if not related to the content, exactly the content, I would say park it for the end. But yes, if something is there, which was the main topic of our discussion in the last sessions, you did not understood, then let me know. But yes, otherwise I will proceed to the databases. Good. Okay. So let me start with the various concepts of databases. Number one, first thing is, okay, let's talk about Today we will be talking relational databases. Yes. Again, I'm giving you some examples here. So when we say relational databases, what do you mean exactly? Yes. So there are various databases. There are hundreds of databases. But today we will be covering a class of databases which are called relational database. Most popular one is the Oracle. Another popular one is SQL, MySQL. Then you have Postgres. Then MS SQL Server. Right? And any other databases, you know? DB2 from IBM.
Mongo.
These are the databases, but yeah, MongoDB is not a relational databases. It's another database, but yes, we are talking only about relational databases. Relational databases means these databases store information in tables. Yes, that means you will have columns in the database where you will be storing various fields, and you will have rows, which is also the record. Yeah, so this is your table. Yeah, table everyone understand. It's like Excel sheet. Yes. So database also, they store information in the form of table like Excel sheets. But they have more features. We'll cover that. Yes. So these are examples of various databases which are available commercially. Out of this one is open source. Yeah, MySQL. And also Postgres is open source. So you can install it in your laptop free of cost, and you can enjoy, you can play around, learn, right? So MySQL and Postgres are what I would recommend if you are doing any project. Use these databases. Yes. MySQL also you can use, and Postgres also you can use. Other databases are also heavy. You may get a trial version, or you may get a free version also. For example, MS SQL Server, you can also install. IBM DB2 also you can get trial version. Oracle also has a free version, which is a personal edition, Oracle personal edition. These databases also you try. So you can choose any of the databases, but yes, for doing any large scale production application, you have to use, I would say, yes, you have to use a commercial version. So better use open source databases. Right. So now I have introduced you with some concepts, which is, say, for example, I told you what are tables. So you should understand these terms. I am also asking you now, let me start asking you guys about various concepts in the relational database. Let me check how much you know. Yes. What is the use of database? Anyone? Why do we need database?
To store the data, like to store that the data, it could be like in form of column and various data type.
Yes, right. So data you can store in RAM. Yes, you can store database in hard disk also, in the form of files. Yes, or database. Yeah, where do the databases store the information? Is it on the hard disk or is it on the RAM?
I think it is on a hard disk.
Yes, it is
Yeah, but
on the permanent storage, right? So now even hard disk is an obsolete term. Now we have solid state drives, right? SSD, a solid state, I think, yeah, it's called like this. But yes, these are the permanent storage. RAM is temporary storage. It is, if you reboot the system, all the data in the RAM is gone, right? There's a problem. It is called volatile memory. And this is hard disk is, I would say, permanent storage. This concept you should understand. Now, next concept is, yes, if you can store the information in files, why do you need database?
What is SSD basically here?
Solid state drive. Yeah. Hard
It's
disk.
It's
Yes.
kind of hard disk or?
Yes. Yes. Nowadays in the laptop, okay, in your laptop, if all of you are using, and
Yeah.
when you switch on, if you get this sound rotating, something is rotating inside. If you feel that something is rotating inside, that is hard disk.
Okay.
Yes. But in the new laptop, you don't feel that, some vibration or something rotating inside. Correct?
Yeah. Yeah.
Yeah, so that's solid state drive, because now there is a new technology which is being used. This is also similar to flash drive. Flash drive is also a different technology. Basically, it's a different technology. Rather than having disk, you have a solid state drive. Yes. Okay. So let me share you the pic if you guys are curious about it. So solid state drive is, yes. So let me show you this picture. I'm just opening it. Yes. Okay. Yeah. You see here, this hard drive and this is solid state drive. The purpose is same. Yeah. You have a rotating disk here in the solid state drive. In hard disk, right? There is a head. It's slower, but in solid state drive SSD, this is the difference. But yes, the use case is same.
SSD we have cache also, I can see.
Yes, yes, absolutely. Right. So yeah, not going into too much of detail, but because
Yeah,
that's
yeah.
not what will be
Correct.
asked in the system design interview. But yes, we will be focusing on the most important concepts which are required for databases. Okay, let me come back to various concepts. So we were talking about why do we need databases, but when we can store the information in files.
Basically, in databases, we can store the information in form of tables, which we cannot do it here. And it will be more organized way.
You can do it in Excel sheet. Yes, you can have, so various file formats are there. You have Excel sheets, right? Excel sheet is not a database. It is just a file. You may export it to CSV, or you can have tab separated files, or you may use a notepad also, or there are so many different ways to store information. Yes.
Yeah, but here we have joining and there's many another operations,
Right,
which we can do. Yeah, like
yeah, so
primary key
basically,
and
see,
yeah.
you should understand very important thing. Anytime if you have the data, but yes, if you have huge data, large amount of data, then becomes difficult to store in files, right? Because in files, you cannot search it. You cannot sort it. You cannot filter it, right? You can do it in Excel sheets, but yes, there are so many calculations you can perform. But when it is a very huge sheet, it becomes difficult, right? What other advantage? If you have information in file in one time, how many people can access it?
I think single person, I think.
Right. Yeah. Yeah. You can have multiple people also accessing it, but yes, it's still not scalable. Right. So yes, you may have file, which is like Google Drive, anyway, multiple people can edit, share Word documents also. Multiple people can edit and share, but you cannot have thousands of users editing, sharing information at the same time. Yes. So scalability is another important reason. So there are various regions, these various advantages of database over file system.
Tarun,
Yes, go ahead.
File is also stored in hard disk and database also stored in hard disk. Right? I didn't understand like
Yes.
what do you mean by file system and database, like what is
Yes.
the difference
Yes.
in the structure?
Yes. File. What is file? File is a storage unit which is managed by operating system. Yes. File means you are storing in an operating system. But in database, you have another layer over file system. Internally, it is going to store in data in the hard disk only, but it is managed by the database or DBMS. There is a concept called DBMS. Yes. In files, you give file name, you can give extension, you can put them in folders, right? This is how you manage files or information over hard disk. But in database, you manage information in tables. You don't have the concept of files. Internally, a table can be contained in multiple files. Got the difference?
Oh, yeah, got. You mean the folders and files of like C drive and all that?
Yes, absolutely, absolutely. Yes, files and folders. But yes, you can do file handling. When you are writing any program, you can do file handling, right? In C, C++ or Java or any programming language.
Yeah.
So if you store information for your application development, because here we are talking about system design, so we are dealing with application development, software application development. And when you are using any information, you have two choices. Either install a database, all these, this is a headache. You have to install some additional software and then store into this info in these databases, the information and access it from here, or readily available is the file system. So I'm just discussing why do we need databases. Yes.
Got it. Yeah.
So basically, if you see, files are efficient. Yeah. Fast and efficient. Databases are more fast and efficient than file system. Yes. Because if you have to load a big file, you would have seen it takes sometimes few minutes also to load a heavy file, right? Big file.
Yes.
But in database, it's never the case. If you have millions of records also, if you have to query it, it comes very fast. So the database is fast. We'll also discuss why databases are fast. But yeah, just know these details, right? Databases are versatile. That means you have a lot of the data types which are supported in databases. You don't have the database data type concept in files. Files, you either store binary information or text information, right? But in databases, you can store data which for say inventory for a data warehouse or for a store, inventory of a store, or it could be some financial transactions, right? Or it could be many other information, for example, some information for your website, right? So databases can store different kinds of information. Files can also store different kinds of information, but yes, I would say that database provides same interface for all kinds of information. Whereas if you have video file, then you need a video player and that will be a different software you will need to process it. And yes, if you have to write the code also to process image is different. Code to process any text information is different. But in databases, you have various kinds of information, which could be inventory, financial transactions, or some data for websites, all could be accessed in the similar manner. Even images, you can even store geographical locations also in databases. So all these information can be processed in a similar manner. So databases are more versatile and they are also good for high traffic. Next is we already talked about is scalability, because files definitely cannot be accessed by many users. Again, depending on the operating system, if you have some personal operating system, then maybe one or two users, few users, less than 10 users would be accessing the same file. But yes, if you have a very network kind of operating system, advanced operating system, or you have a cloud environment, there you can have multiple users accessing the same file.
And also I feel like
databases are more scalable. Yeah, go ahead.
no, I also actually feel like let's suppose if you will talk about file, right, and database. So database will be on server, which can be like used
Yes.
by any
Yes.
developers or any another people.
Right. Yes, usually yes. Databases are, but yes, you can have files on the server also. File servers also can be there, right? And you can store information in a file server somewhere else as well. But yes, database also uses, especially, yeah, they can also run on server. But yes, this is common for files also. Files can also be on the server. So next thing is
But
security.
credential wise, if you think about, let's suppose in database, we can set the credential, username, password, URL kind of those
Absolutely.
things.
Yes, absolutely.
But in file, we cannot, I think, right, manage that.
Yes. You
We
can
have the
have some security in file, but you can have row level, table level security in the database. In database, you have control that maybe if you are storing employee data, then I will only allow salary information to be available to HR, right? But yes, this you cannot do in file system. File system, either you give permission to access everyone or everything, or you restrict access to everything. Yes. But in database, you have higher security. But again, no, operating system do provide some security, but the security can be compromised. Hackers know how to even access any hidden files also. Yes, so security is not that tight in file system, but it is very tight in databases. Yes. Another factor. See, now we are coming to all these things. These things are coming again and again, which we called earlier. I called it analyses, right?
Yes. That is called non-functional requirement.
Yeah, non-functional requirements, right? So security, reliability, scalability, basically here we were talking about performance, right? And efficiency. And so, yeah, these are all various reasons why databases are preferred over file system, right? Reliability is also, databases are more stable applications. Operating system, they crashes, you have to reboot a lot. If you are using Windows, then it has to be rebooted multiple times a day, and your users will be feeling very bad because during the time when the reboot is happening, file definitely will not be available for them to access. Yes. So these are difference between databases and files.
And we don't have clustering kind of in file, whether we have in database like
clustering of file servers.
Like for example, if you have master slaves and
Yes,
all
master
this
slave configuration and all. Yes, you don't have. Yes, reliability, because you can take backups. Yeah, you can take backups of file also. But yes, the databases provides various other features which are much more advanced, because the purpose is to build applications, to support applications, whereas file system is just to store some information. And the use of file system is different and use of database is different. Databases are more suitable for applications. But yes, databases do have some disadvantages. So these are the advantages which we discussed. But yes, let's also discuss some disadvantages. So yeah, this I would say are advantages of databases. These are advantages. And yeah, let's talk about disadvantages. In disadvantages, what do you feel is disadvantage? Yeah, you need a database administrator, right? For databases, it's costly, it's complex.
Yes.
Yeah, more complex. File system is simple, and here it's you need training because file system, yes, you can very easily use, read, but yeah, database information reading is difficult. You need training, and yes,
We need
database,
we
yeah,
need
may
data.
require debugging, and sometimes yes, you need more complex support also for databases. Yes.
We need database developer for that actually sometimes.
Yes, you need a database developer. And once you have defined a schema, basically what you do is in any database, say, let's say this in table is employee table, right? So when I do this, I will say that, okay, my employee will have ID, my employee will have name, my employee will have, say, age and say salary, department, right? So other fields I will have in this. So once I define all these information, it is difficult to change in databases. Yes. So it is, I would say, less, it is rigid, right? It's databases are rigid. This is what I mean, that they are inflexible. Once you have defined the structure, you have to store that kind of information only. But in files, yes, you can enter a text, you have more flexibility, easily you can update things. So these are the advantages and disadvantages of databases. Right? Now, these are very basic concepts. Let's move to some good concepts. There is very important thing, which is structured query language. It's called SQL. Sometimes it is also pronounced as SQL. So, okay. Now I also see some questions. Let me take that questions which are there in the chat. Before I move to SQL, this is the next topic. Yes. So, okay, some people did not understood the security and reliability. Yes. Reliability, I told you, if you are storing information in the file and it is Windows operating system, you would have to reboot your operating system multiple times a day. Yes. Windows crashes a lot. It's not reliable. But a database server, you may be running it over Linux. Yeah, you will be running in some big server. So there it is reliable. You don't have to reboot it every day. It can run for many days, many years also without rebooting. And so that's reliable. Secure is, we discussed that files can be hacked. Yes. You may have password for the files, but still hackers know how to hack it. It is less secure, but in databases, there is more security features available. Database also, when you install on databases on any operating system, you have to get the exact same executable, right? So databases are dependent on operating system, but all the databases which I shared, the list above, are available for all the major operating systems. So probably in Oracle, and if you are running it in MacBook, there could be a problem in this. But yes, MySQL you can run on Windows, Mac, Linux, Unix. Postgres you can support. Yeah, you can run on Windows, Mac, Unix, Linux. Same is for others. Yeah, maybe little bit differences may be there. But yes, the databases are available in all the operating system. But yes, you choose very stable operating system and then run a database, which is a specific database software, which is for that particular operating system, right? For example, Excel, yeah, you have it in Windows. I'm using Mac, but I also have Excel in Mac. I also have Word and PPT in Mac. But yes, there's no difference whether I'm using in Windows. I learned PPT creation in Windows, but I am able to use the same in Mac also because there is no difference. Same is the case with database also. The software is the same. There is just a porting of the software in that particular operating system. So yes, if you know the concepts, you can apply in any operating system. So this was answering to Funny's question about is databases dependent on operating system?
Hello, sir.
Yes.
So both are dependent on operating system. In file system, the OS crashes, but what about database? If you are putting more data, does OS crash?
Yeah. Yeah, this is more stable, right? So it will not crash the OS. In databases, you can put large amount of information and without making the OS crash. Now, why with file system OS crashes? Because file system is designed for storing small files. But databases are designed to store large volume of data. So they will not crash because they are tested on it and they are stabilized, right? So you will have more reliability in databases. Got it?
Yes, sir. Got it.
Yes. Okay. Great. Now we don't go into very specific details because Nivin is asking about ATP. Now there are autonomous databases also, so where MLAI is used to replace admins. But yes, I'm not going to cover that. So just ignore it. We will cover simple kind of databases. Maybe we can discuss that in some post-session discussions in case you need it, right? But yes, don't worry about it for system design. So let's talk about SQL because SQL is very important. It is important for low-level design. It's also important in high-level design also. So SQL is a query language. It's as shared in the full form. And it is a language which can use to retrieve information from databases. Yes. It cannot only just do query. Yeah, the name is a little bit confusing. It can be used to create the database tables. It could be used to modify and update the data. It can retrieve the data. But yes, primarily it is designed to retrieve the data. But yes, it has much more capabilities. Now let's talk about, we'll cover into the syntax. We'll cover the syntax of SQL later in this class. So let's talk about few other terminologies. We will dive into the database. What are various concepts which are associated with the database? So what you should understand is what is a schema. When we talk about database, you should understand what is a schema. What is a schema? Anyone? No one knows what is a schema? What is database schema?
Skeleton of
yes, is
structure of data.
Organizing the data. So the schema is your organization of data or a structure of data. Yes, a structure of data and its relationship, right? So this is very important when I'm talking about a relationship. Relationship is a very important concept because the database is also called relational database. In our case, we said, this one. This is a relational database. So the concept of relations are very important. Let's understand the concept of relations also. But for understanding relations, we have to understand tables. Tables, now I told you this is table, employee table. This is columns. Columns also, ID, name, age. These are the columns. Rows also, row is a record. Yes. So for example, I may have a person with ID 1, name, say Tarun, and then maybe some age. You can have various data entries for the person. So this becomes a record. Yes. So let me try to put this in the line so that it looks like, you may have some age also for some person. Yes. And this is a record. Yeah. If I want some more records, I may have here, say some other person, his age, right? Like this. So this is another record. So you may have multiple records in a database like this. This is, and each of the row is a record. That means is a different entity or object. Yes. So this one, okay. Let me say this you understood. This is the row. Okay. And this thing is the column. Yes. And table, you understood, right? And rows are also known as records. Columns are also known as fields. Yes. So do not confuse. These are the same thing. Okay. Now type. And rows are also called records. Yes. Tables are also called relations. Yes. This is what you should understand. Right. So now let's design some database. Let's talk about a database which is for mapping an employee, right? So how do you design a database? I am coming back to ER diagram, which we talked earlier. So in one of the class, we talked about ER diagram. Yes. ER diagram. This is similar to class diagram. Class diagram is used to do object-oriented design of any application software. Same way, ER diagram is used to do the design of a schema for a database. Yes. So I'm asking you to store employee information. So employee information you will store with some fields, right? So I have ID field. Yes, I have name field. I have age field, right? And there are more fields also, but yes, for convenience, I'm just drawing few. And then these are connected to employee object. Yes, so this is how you draw an entity in ER diagram. Yes. And if you want to depict that, okay, ID is the primary key, you can underline it. Yes, or underline it. Or the other way to depict is you draw like this 2 circles here. Better to draw this 2 circle is a standard convention. And yes, so let me try putting like this.
It can be drawn like this as well, right? Like I have actually pasted you in the chat. So generally I have seen this way.
Oh, that's a class diagram. Yes, this is a class diagram. Yes, database schema can be described in the class diagram format. That was also what I was covering. So how do you define a class? You will use a rectangle to define a class, right? And then in the class, you may have various attributes, which is ID, name, age, and you may have some methods also, because in any programming language, a class will contain methods and it will contain attributes, right? So a string could be, say, integer. You may have name as a string, and this again is the integer, right? So this is another way of depicting. Both are same. Yes.
Both are same, right? I mean, either that way or this way.
Whichever you prefer, you can draw. Yes, in system design interview, if you prefer this one on the left, ER diagram, you can use that, or you can use the class diagram. Class diagram could be used to depict your database also. Yes. Now, important thing is, you may also want to store some more information. For example, departments, right? Or manager, right? Let's talk about some other information, or let's talk about projects, right? So let's say we're storing project information. Yeah. In project information also, you may have a ID. Yes. You may have, say, project name. Project will also have the name. You may have a manager also, right? So in the project, you may have a manager. Yes. And then you have a project name, and you have here the ID, right? Say, let's say these are the information. Again, these are the attributes for project. So you have to connect this, right? And here ID again is the primary key. So let's draw a double circle to represent this. So this is your primary key. Yeah. But yes, important thing here is projects are also related to employees, because employees are working on projects. How will you describe that information? Yes. So the way you can describe is, you can describe this is a relationship. Yes, so your employees are working on projects. Yes. See, important thing to note here is, you can have multiple employees. I'm denoting. You may have a project. Assume project cannot have 0 employees working on it, or yeah, it can be. You have the project, but the project is not started. So let's say project can have 0 employees. Project can have 1 employees or more employees also, 1 to any number of employees, right? Based on the size of the project. It could be, say, 10 people project or 100 people project, or any number of people can be working. So I'm denoting the cardinality here, that 1 employee can work on a project. Okay, now there is another direction also. Yeah, we'll discuss that also. So, but yeah, project can have any number of employees. And an employee can be working in 0 project. He's in bench. That means he's in bench. Yeah. Or he may be working in 1 project, 2 project, or maybe 3, 4 project, right? If he is a manager or if he's a CEO, he may be taking care of hundreds of projects also. So you have many to many relationship here. Understood this many to many concept? Yes. So you have here also the relationship, which is employee and projects. Yes. Maybe for relationship, you may have some more attributes also. For example, for assignment, yes, you may have, say, billing rate. Yeah. We may store it here, because maybe an employee can have a billing rate, but yes, sometimes this billing rate is a standard, but sometimes it may vary from project to project. But let's assume in this scenario, we may have an employee which may be billed for, say, $100 per hour in 1 project, but maybe billed on, say, $50 per hour in another project. So in that, you may want to store this in this association field. Yeah. So this is, you may have attributes in association also, but because this is many-to-many association. Yeah.
So Tarun, just want to understand that whenever we are going to talk about like many-to-many relationship in the entity diagram, then in that case, we have to represent that relationship with O, the triple dot
Yes.
star.
Yeah. 0 to star means this is many-to-many relationship. Yes. Yeah, 1 to star, 1 to n, you can use whatever you like. But yes, this is how you represent many-to-many relationship. See, this actually will come in this arrow, this line.
Right.
Yeah.
Right. Yeah.
This will come. Yes. Right. So same you can represent in class diagram also. And in class diagram, how you specify is you'll say here, this is project. Yes, the class name. And then you will have the attributes. So you understand that. But yes, you may have a line connecting it. And sometimes you use this crow feet to denote this is many-to-many. Yes.
Tarun, what is the common field between the employee and the project name?
Yes. See, you need ID. Yes. So the table, which is assignment. So basically, let's convert this ER diagram to the tables so that it will become clear to you. Okay. Employee table I did already. So I will try to copy it from here. Yes.
So you're saying that employee ID will be joined with the project ID.
Yes.
But I think there should be, I'm just thinking that there might be extra column which required.
Yes, yes, right, absolutely. So this is employee table. Yeah, some item did not get post, but yeah, I hope you understand. This is your project table. Yeah. So in project table, you have details of the project. So you have here ID, you have project name. Yes. And you have, say, some other details also, project name, say, let's talk about manager. Okay. Yeah, these are the details you have in this project. There may be a project ID, which is say 1. The project name could be, let's say, let's talk about one project. Let's say tiny URL is our project. Yeah. And assume there is a person who is a manager for this, say Sunil, right? Sunil, yeah, we don't have to put this detail because more efficient is we know the manager. So manager could be the ID. Yeah. So here we, instead of putting the entire name, because someone may have a very long name, we just say put 2. Yeah, this is your details about who is the manager, who is the project. But yes, if I want to store also this information, how many employees are working in this project? How do you know? There is no way now you can store who is working in which project. You only have information about who is the manager for that particular project, but in the project, there would be many employees which will be working. So you need another table, right? So this is your employee table.
Okay, mapping table, basically you are going to.
Yes, you need mapping table because it's a many-to-many relationship. Yes.
Okay, we cannot do in a single table, right? If it is one-to-many, then we could have added extra column and then probably.
Correct. Absolutely. Because see, manager to project is also a relationship. Yes. Which is, but you will have only one manager for a project. And a manager may manage multiple projects. Yes. So if suppose there is another project, say 2. Yeah. Let's talk, this project is. Yes, this is another project and same person could be the manager for this project also. So you represent Sunil is also the manager for this particular project. Yeah. Let's say we have more here. Employees, yes. Let's say we have Radha and let's say age is 24, some different numbers we can use. And if we want to store that information that in one project we have Tarun working and another one Radha working, how would you depict this? This is what you will need a relationship or mapping table. So in this table, the way you will depict this is, you may just say that let's say you don't need actually, yeah, this one you don't need. We'll have just the employee ID and the project ID. Yeah, basically, sorry, this is your project table. Yeah, and then you need here employee ID and you need here project ID. Yes. So to say that Tarun is working in tiny URL project, the way you can do is you can just put 1 and 1 here in this row. In the other row, you may put, say Radha is working in, say, the other project, which is delicious. This has the ID of 2. You have this, right? So this is how you will be representing the information that there is a relationship between these employees are working in these projects.
Tarun, I have one doubt. In the employee table, we can directly add the project list of project IDs, and we can add the list there, right? Employee table, we can add a project list of project IDs, and there we can add list.
Yeah,
of
but an employee can work in multiple projects.
Yeah.
Right. So assume Sunil is the manager for both the project. So for him, what you will put? Yes.
Could you repeat the question again?
Sunil is working in both the projects.
Yeah, that is the like list of projects. The column contains column is a list of
Array.
projects.
You need an array in here.
Array.
Yes.
So we can do this way, right? Like why to split it into a new table and mapping there. I know like updation, relation, this takes a lot of time.
Yes, yes, right. So I'll tell you. Yes, let's discuss that. This is a good question. Assume this is one example, but yes, maybe he is the manager for, assume he is the CEO. He's working for many projects. Right. Yes. Great. Assume like this is the data. We have so many projects, but yes, I'm not putting all the data. Now you have to find who all are working in project ID 2. Yes. Performance is getting to be slow for you now. Because you have a big list here. You have to do a search, maybe binary search, or you have to figure out, sort it out first, right? If you want to efficiently search it, or you have to do a linear search. It will be very slow to figure out whether this person is working in a project or not. Yeah, because you got the array. Yes, is not advisable. Only use one value per column. Yes. So this is bad design. You know why? Correct?
Yeah, understood.
Because now here, the way you will represent is, you will say, Sunil is the employee ID 2. So we will say 2. And we will say, again, he works for 1 and he works for, so we will add another row. Yes. So this is 2. Yeah. So see, now there's no such performance problem. You will just filter this. And
Will there be a primary key for this table mapping table?
yes,
What and
primary
what
key,
will-
yeah, you will have because can use a composite key. Combination of both can be treated as a primary key. Yes. But yes, tell me what is a primary key? I have not shared this information. What's a primary key?
It's a unique key.
Is the key which uniquely identifies a record. Yes. So
Yes.
this is the primary key. So in this table, where let's call this works table, right? So here in this particular table, you may have employee ID, project ID, combination of both as a primary key. Yes. For employee table, you have the ID as primary key. I'm just putting PK. Yes. Project. And is here again, project ID is the primary key.
In mapping, why we are using that composite primary key kind of here?
You may introduce another key. Yeah, if you want. See, you can have always multiple right answers. But then there is trade-offs which you have to think about. Yes, let's call it. We have again another ID, maybe work ID. Yeah, we can create another ID.
But what we will do with this ID? Like work ID will not be using, right? Basically, like we just need mapping between employee ID, employee and project table.
See, you are introducing one more ID, adding more data. Yes.
Yes. So just
So
wanted to
that's a disadvantage. Correct.
correct. So I don't think so. This is actually required because we are ultimately
Yes.
not going to use that.
Right.
But if you talk
But
about
yes.
employee ID and project ID, right?
No, I tell you, no, because there could be more columns here. We have one column here, billing rate. Right. So here, say, assume we have this column, billing rate. Yes. So yes, now you may have multiple other columns also, like project joining date, assignment date, or project completion date. Maybe employees assigned to a project for particular time frame also. So you may have a start date and date for that particular project also. So yes, you may have more columns also here. So in that case, you may choose to have a new ID, or you may choose to have a combination key as a primary key. Yes.
Okay, but Tarun, this is just a mapping table. Do you think that we have to add extra column here? Because this is just mapping.
Yeah,
table,
where
right?
will you store billing rate? How will you
Mm,
store the billing rate? Yes.
okay.
Because billing rate is different, right? So you need, how will you assume there is a start date also? This is for an employee start date. This is not the project start date, but yeah, an employee may be assigned for this project from date, say 1st of June to say 30th of June, but project may be longer. Some other employees are assigned. So if you have
Okay.
to store that kind of, you need attributes.
Okay. So you're saying that if you need that billing rate or start date related information, then
You
we
need,
can get it
yes.
from work ID.
Yeah, you may use work ID or you may use the combination. It's up to you which one you prefer. They have pros and cons. Work ID is additional field you are introducing when you can just use a combination. Why to have this?
Yes, correct. That's what I'm
But you
thinking.
may say, oh no, I want a simple one because primary key probably no should be single one and that would be more effective. So you may have that also. No problem
Okay.
with that.
But composite can be also used here just by combining.
Yeah, but yeah, composite works. Yes, there is, you don't gain too much because these two composite key will be good. Yes.
Mhm.
So yes, this is the consideration which you have to do. So this is about primary key tables relations. There is something called foreign key also. Yeah. Let's have another table, which is who manages employees. So let's say, yeah, maybe we will, yes. Okay, let's talk about some other relationship where we will discuss the concept of foreign key.
Even here, manager ID itself is a foreign key, right?
Yes, yes, absolutely. Yes, correct, correct. Yeah. Yeah, this example can also be used for very nice. See, you guys are very smart people. You know, yes, lot of things. So manager ID is the foreign key because this needs to be existing in an employee ID. Yes. If I put something like 5 here, invalid data, assume you have only these 3 employees. You can very quickly figure out that this is invalid data because employee ID 5 do not exist. There's no such employee. So foreign keys are the keys which are used to link data from the other table. Yes. Now, if I ask you, give me the name of manager of tiny URL project.
Okay.
You
So
will use foreign key for that. Yes.
so 5, why we are thinking invalid? Tarun, just one.
5 does not exist. There's no such employee.
Okay. So okay, you are checking from the employee table.
Yes, yes, right. So this is important for data validation and also in retrieving information also, right? So I'm just putting back 2 because yes, it's important because if I ask you, give me the name of the project manager, you can say, okay, the manager ID is 2 and name for the employee who is having 2 as ID is Sunil. So that's why you can give me the name of the manager of a project. But yeah, we are not storing that data. But with the help of foreign key, we are able to find out this data. So foreign key adds efficiency. Yes.
So can you say the field name as manager EMP ID? So I think that will actually make the relationship here. Like as you have written manager ID. So
yeah,
just
you can give anything. Yes. No worries. Name alias. Name is like variable name.
yeah.
So just you have to think logically they are related, but yes, need not have to be the same name. It could be different names. Name should be intuitive. Whatever you feel is intuitive. Because if I put employee ID, then you will get confused. Yeah.
Yeah. Manager EMP ID, I was saying.
Correct. Because assume you have a manager. You also have someone who is the QA manager also, or you have multiple different kinds of roles then in a project. Then if you use employee ID, then it becomes difficult. No, you won't be able to figure out who is the manager ID. Yeah, so keep it intuitive name so that this becomes easy to understand. Yes. So hope everything is clear. Foreign key, primary key. Yes. Now another important thing is indexing. Yes. Assume I have a query where I want to ask all employees who are over the age of 23. Yeah. So I give me employees who are older than 23 years. So you have to go through all the employees, see if the age is more than 23 or not. In this case, one employee is having that, right? Meeting that criteria.
Yeah.
But there may be many employees also. So sometimes it is good to index the table What if we sort this table in age? Yeah, or it could be salary also. Assume we have salary also. So you may sort the table as per some column. Yes, because if you need the sequence in that order frequently, you may use index for sorting. So what actually will database will do? It will create an index. Index is like an index of the book, which is a separate data structure. But yes, it can help you find out things in a particular order. Assume I have here salaries also. You see, this is salaries 100 rupees. This one has say 120. This one has another person. Yeah, this is having salary of 110 like this. So now if you ask, okay, give me employees who are having salary more than 110. That's another sorting I need. Yes, but I can't sort the same row in multiple sequences because age and salary may not have any relationship, may not have any correlation. So in that case, I need to sort the table in two different ways. So I may create two separate indexes, one for age, one for salary. This way, I will be able to retrieve both the information very fast, right?
Karan, can you tell that indexing part once again? I mean, what is the basics of an index and why do we want and how do we create?
Yes. So basically, index is a separate data structure. There are different kinds of index available. But yes, you can think of index is some separate data structure here. And they are pointers to the data. So let's say this is the age index. Similar will be, I'll name it like the age underscore index. Yeah. Or yeah, age hyphen index. Let's name like this. So the way it will be there, it will be a structure which will be lowest age is 22. It will be mapping here. Yeah. Let's say this one. Then just thinking that is there any curve arrow, it's easier. But yeah, no problem. You'll have another line. Next is the second item is you have a pointer to 23. Yes. Yes, this one. Third item is pointer to 24, right? Need not have to be pointer here. Pointer to the record. Yeah, it will be pointing to the record. Right? This is how your indexes will be. Yes.
Okay.
So now you
so basically it is kind of storing internally as a column. I mean, it will not be visible.
Yes, yes. These are pointers and these will be storing the sequence.
Sequence like in sorted order or
Yeah,
something like
in
that.
the sorted order. Yes, absolutely. Actually, if you want to understand how it is done, this is the B tree. B tree, you know, now data structure. I have
Binary
to
tree?
dive into. No, not binary tree. This B tree is different. B tree is not binary tree, is a different kind of tree.
Okay. And just want to understand how will get
Anyone knows
benefited.
who knows B tree? Yeah, go ahead.
Yeah, I just want to say like how we'll get benefited. Let's suppose we have age index exist, which is not visible, but we know that already indexing exists in the table for age. So let's suppose if you want to search for age greater than 24, so how will get benefited here? The age greater than 23, for example. So
yeah, you have the ordering, right? So you will
indexing means we have ordering.
yes.
So
Yes. Okay, now I'll tell you, right?
but the query will be same, right? Just indexing exists. That's why it will give that very faster. Is that, or we have to do something else extra to basically make sure that we are going to fetch it from with the help of index or salary index or something like that. Just wanted to understand on this.
Let's understand B tree. You will understand now. Okay. B trees are a data structure. Let's say the ages. We have employees, like let's say one employee is there 23 years. Yeah. Then we have an employee who is 22 years. I am forming a B tree. Then we have an employee who is 21 years. I'm inserting in random order the ages. Yeah. Then we have an employee who is 24 years. Then we have an employee who is say 27. Right. Let's say now we have an employee which is 18 years. Let's say 10 employees we have. Yeah. Let's insert few more. Say 34. Let's say 21. No, 32. Let's say, see, these are the employees. This is my tree, B tree. Yeah. Now you tell what do you want to get from this information? Assume now this is my B tree. This is the index.
Okay.
It's hard to draw in that, but yes, I have drawn here. Able to see it properly? See,
Yes,
this is not a binary tree.
Okay.
Because you see here, this node has two values.
Yes, yes.
18 and 21. That's the difference. Yes.
Yeah.
So you may have, but yes, you know, and you can do the range search here. The advantage is you can do the range search. You can find who is having the age 32 also very fast. Because here you go and then see the 24, it cannot be on this part because this is all values lesser than this. But yes, on the right side, it is 32. But yes, if you say, I want to know all the people who has age in the range 18 to 25, you can do that also using B tree. Right. So that's why we use B trees, not hash maps, or it's not just the pointers, because you may need range queries also. Give me employees who are in the range of 24 to 28.
Okay.
Right. That information is available here.
So basically, like as ID, I mean, age index does not visible, right? It does not visible, correct, in table.
Yes. It's
So,
not. It is.
So let's suppose if you're writing query, select star from imply where age is greater than 23.
Yes.
So will this actually use this indexing here? Internally?
Yes, absolutely. That's why the indexes are there. There is a database engine which will be giving you the rows.
Okay.
Right. It will be using the indexes to find out what are the values there.
Okay, so if we'll delete that age index, that means it will work slow as a linear search.
Slow. Yeah, it will become slow.
Okay.
Because it will then try to manipulate, do it manually, right? With index, you can do fast. Yes. But learn about B tree, go through yourself B trees. And in case you have doubt, we can discuss next time.
Sure. Thank you so much for your clarification, because I have heard many times indexing, but I was not getting that how the indexing actually. I know indexing internally something will happen, but it will not be visible as extra column.
Yes.
But still, so like that, whatever number we have, we can do indexing for all the things. So do you think that while inserting the data only it will do indexing, or how, when it will be happening? So
Yeah, you may update the data also. Yes.
later
You
on,
may
so it will
delete
not
the
slow
data.
insertion. Insertion will not be slow here.
Say I'm deleting something, like let's say I delete 23.
Okay.
Sorry, this is fine. So I should put here 23. Yeah, delete, right? So it's trying to search and it's showing you animation. Now, be index has modified. Yes. I
Yes.
may insert also some other value. Let's say instead I would 25 as I insert 25. Yes. So if I insert 25, let's see where it is. It's inserting here, right?
Right.
Let's say want to find some number. Let's say 28, which does not exist.
Yeah, got it. It is trying to search.
Not
its-
found, not in the tree. Yeah. So
Yeah.
see, this is how it's showing you the algorithm also.
Correct.
How is going to search. The same database engine will also do this. Right?
Okay, so basically, like while when we have created indexing for A's, so while insertion, it will not slow down, right?
Yes, yes. You know, it will slow down because you have to insert you have to create the index also. Yes.
Right. So it will slow down, right? Yeah, yeah.
Yes. Query
Okay.
will be fast. Insertion will be slightly slow.
Okay. Okay.
Addition, insertion, updation, all will be slightly slow.
Mhm.
Always there is some cost which you have to pay. So if you have too many indexes, then your performance of adding item may be
Too
better.
much slow.
Yes.
Yeah, yeah. Correct. Thank
Right?
you for
So
clarification.
unnecessary, you should not create index because memory is wasted as well as some delay is also there because of index.
Sure. So I can see like deletion is fast, getting the information is fast, but yes, insertion is getting slow here.
Yes, yes. Deletion is also slow because you have to delete the item from the index, delete the row also, and change the indexes also.
Okay. Yeah, yeah, yeah.
Yeah,
Correct.
you
Correct.
saw that. So only thing which is fast is searching.
Searching. Yes, yes.
Rest everything is slow.
Slow.
Yeah.
Okay. Okay.
But
Thank
searching
you.
you'll do more, right?
Yeah, yeah, yeah.
So that's why, for information where you have less creation, insertion, deletion, but more searching, indexes are fast.
Yes.
But databases where you have more deletion and less reading, then that is a problem. Yes.
Yeah. Thank you. Thank you for clarification.
Great, great, awesome. So hope now everyone is clear until now. Let's move to some more details. Yes. Let's come to acid. What is acid property? This is another important topic. Acid is basically a full form. Okay, better I will keep it like this only. So let's talk about all the relational databases are acid. That means there are 4 things which you have to. One is atomicity, other is consistency, then isolation, durability. Yes, this is what means, this is what is acid stands for. Got it? Now let's look into each of these property. Atomicity is, assume we have a bank account. Yeah, we have a database for bank. In that, someone is doing some transaction, which is transferring money from, say, person A to person B. So the database, in the database, you will have 2 records. One record is for person A. Other one is for person B. So you have here account number. Say, let's say person 1 has account number 100. Person 2 has account number. Person B has account number 200. Let's have the name also. So here the name of the person is A. Name of the person is capital B. It's difficult now. Okay, let's say A I save capital A, and B, let me move this everywhere here. Oh, B also is moving. Okay, let's delete this and get another B. Yeah. Yes, so you have these. Yes, so this is how your table is. This is the account table. Yeah. These are your columns. And the balance, you need also balance. Say A has initial balance of 500. B has a balance of say 50 rupees. We are transferring rupees 100 from A to B. Yes. So 100 rupees transfer is there. A is paying 100 rupees to B. Let's say this is the transaction. So what do you mean by atomic transaction? Atomic transaction means that two things will happen here. A's account will be A minus 100. B's account is B plus 100. Clear? But yes, if one fails, assume this transaction fails. Right? And the second one succeeds. Yes. Who will pay the money? Bank will pay the money. Yes.
Yes, yes.
Correct, correct. Or
Both-
the other way around. Yes.
Both person will become so happy.
Yes, right. Correct. No, but the other case is both will become unhappy also, because yes, there is equal probability that yes, you have most of the time, yeah, this happens to
Correct, correct.
this fails and yes.
Deducted but not credited.
The other one is passed. Yes, yeah, correct. So yes, so generally if sorry. Generally situation is less tricky. Yeah. So atomicity means that either both of these will success or both of will this fail. So database ensures that when you mark some operations as a transaction operations, then either both of them will succeed or both of them will fail. Clear? This is atomicity. Now consistency. Consistency is assume you opened an account. Yeah, you are person A. You have the balance 500. Now you don't do any operation. Come after 1 year. Your balance is 0. That's not consistency, right? Maybe you check your balance, it's 500. Again, you check it is 400. Again, you check 300 without doing any operation. No one is adding money or no one is withdrawing money. If the data is changing, that is also not consistent. So consistency is about that once you store some information, that should stay permanently there.
But
This is consistent.
it may be charges from bank also, right?
Yeah, that's charges are other thing, but yes, there is a transaction for that. But yes, if there are no charges, nothing is happening, then yes, the amount should stay the same. Yes. Any data, age also, if your age is now, you said, okay, 30, and then after 1 or 2 days, it should not change. Yeah. After a few years, it changes. Okay, it's fine. But yes, the once you have entered some information, should be there permanently. That is consistency. Next is isolation. Yeah. Isolation is another important thing, interesting thing. What is happening is, let's say, yeah, A is giving money to B, B is paying to C, right? Say 100 rupees A is transferring to B, and at the same time B is transferring 10 rupees to C. Yes. So when these two operations are happening at the same time, one group of query should not affect the other group of query. Yes. It should not happen like, yes, A got 10 rupees deducted and B got, yes, also 10 rupees deducted. Yes. So that is again a problem, or B got 100 rupees deducted. Yes. So isolation, both the operation should happen in isolation and it should not influence each other. Yes, this is about isolation. Yes. So we covered atomicity, consistency, isolation. Then finally, the last thing is durability. Durability means that, okay, assume the database server crashes. Yes. You have to restart the server. So after restarting the server, still the balance should be there. This is about durability. Yes. Similar to consistency, but consistency is having more meaning. Consistency means the data is valid also. Yes. But durability is only about the data should be there. In case of failure also, it should not lose. It should not lose. So that's the difference between consistency and durability. But yes, this is the ACID property. All the databases, they conform to ACID properties. And because of which we use file system do not have this ACID property. Yeah, because you may store a photo and then after sometimes you come back, you see the photo is corrupted, video is corrupted. Yeah.
Hi, Tarun.
Yes.
Yeah. These are the concepts that SQL database should follow, right?
Databases. Yes.
Okay.
No SQL will not follow this.
Okay. I have a lot of doubts here. So whenever I implement database, for let's say bank table, balance table, if I have to implement atomicity, how should I define? It's like the to implement atomicity.
In NoSQL or in SQL?
In SQL. In SQL, there are two transactions, right? This is a concept. Atomicity, like there are two transactions. Both should happen or none should happen.
Yes.
But
syntax, you mean you need the syntax for SQL queries? We'll be covering that.
Okay, like I want a SQL query where we implement the atomicity.
Yes, right. So that I will share to you.
Okay,
we'll be
sure.
covering in transactions. Yeah, there is much more details also required here. Locks are also in there. There are lot of concept about transactions also, and there are different kinds of transaction and transactional consistency. So we'll cover there. I will give you the example.
Sure.
Yes.
And yeah, and one more doubt. When we are doing transaction, if the bank account of one person is SBI and another other person is Axis, so during that case also this atomicity applies, right?
Yes, right.
But
see, that's through the logic. Yes, because you have the UPI application or you are transferring using net banking and all. So there is a different thing, but yes, that has nothing to do with the databases because these are across databases. ICICI may be having another database because database can only take care of itself. It cannot take care of other databases. Yes, there's no linkages. Yes, between these two databases. But yes, that you can always handle at the application side.
got it.
Right. So only it can be done at your application.
Yes.
I'm not sure like if the ICICI has handled, for example,
Yes.
obviously it is bank.
That is taken care through the logic of that money transfer application. Maybe some money transfer application you would be using like GPay or UPI or Paytm. They will have to take care. Ensure that yes, money is removed. See, you have this payment gateways, MasterCard, Visa. They do that only. They ensure that when the money is transferred across countries also, they do deduct charges for it. Yes.
Yeah.
But
Since
doing that,
you
for
asked-
ensuring atomicity, they deduct charges, transaction fees also they charge.
Yeah.
For
Since
that.
you gave that example of real world bank,
Yes.
so I got that. Okay.
Right. But I'm just talking about assume these are the two people in the same bank. We are dealing with the same database.
Got it.
Yes, in the same bank.
Yeah. Okay. And coming to the consistency and durability, you told ACID properties are like not for NoSQL, right? But without consistency and durability, like how database works even for NoSQL. So I didn't understand that part.
Yes. So yeah, that I'll cover when we will cover NoSQL databases. But yes, for now, I will tell you that you don't need consistency all the time. Say, for example, you shared a WhatsApp message. After 21 days, it's gone. Yes. You shared the image or something. Yeah, you may have self-destructive. Sometimes it's fine to have the messages deleting after some time. So you don't need durability. Consistency also, sometimes you don't need. For example, all transactions are not bank account transactions. Sometimes it's fine. For example, when I'm updating my profile, yes, maybe I have updated my profile pic in LinkedIn, but you are seeing my old profile pic. Other one is also other person is seeing the new profile pic. Yeah, that may happen that for some time, there is inconsistent state, which is also known as eventual consistency, which we will cover in later classes. Because yes, I'm not saying they will never be consistent, but what I'm saying is there can be situations where there is inconsistency.
Got it. But that is not at all like that is because of the replications, right? That is not to deal with what
absolutely.
That is not to deal with what is the database you are using. Let's say in the first case, when you're
Replication
told
is the feature of the database.
Replication
is the feature of the database, and they do not guarantee all the time consistency. But relational database say that there will never be a situation where any of these things will be compromised. All the time, 24/7, there will be atomicity, consistency, isolation, durability. Other databases say that we will do that, but there's no guarantee that all the time you will see consistent results. or
Uh,
atomicity or isolation or durability. Sometimes atomicity may also not be there.
I still completely didn't I didn't understand completely in the first
But yes,
yeah, in the first
just
example where you
understand.
told WhatsApp
Yes.
messages,
Yes.
you told after sometimes they will get deleted, right? After 20 days or something. That
Yes.
is the eviction policy of the database, right?
Yeah, that's
That can be SQL or no SQL. Uh, so it is not like there can be the database which we used and eviction policy we can set. There can be SQL or no SQL.
okay. Okay.
So in that case, like if I
Yeah, but
used
you don't need durability. You need only for 21 days. Yes.
yeah. So if I
Right.
use a SQL database and I kept the
Yes.
eviction
Either
policy as
you are deleting. So there are two ways to implement. One is you have a script which is deleting some of the rows, or you are completely throwing away everything. Yes. So durability is important. So you may say that in relational database, this is very important. You cannot live without it. Yes, in other databases, it's not that important. Now, how you get that and all that implementation detail is other thing, but conceptual level, this is the fact. Yes, you should understand, and no need to go in depth at this stage. We'll go into that depth when we'll be discussing system designs.
So by default, these properties will be there as we are choosing
Yes,
the
you get it for free. Yeah.
yes, yes. As
Get
we are
it for
choosing
free
the
in
MS
relational
SQL
database.
or
Yes.
yes,
Relational
SQL kind.
database, but yes,
Yeah.
you cannot assume this in non-relational databases.
Yes, and to achieve, I think it. Let's suppose we have programming, we can apply some like I've seen that like maybe Spring we have some acid related things we have to mark or
Yes,
something like
yes,
that.
right. Yes.
Okay.
Because
One thing I just want to
in
understand
high
between.
volume, yes.
Mhm.
See, you will understand this in high volume. It happens that even when you insert data, data is not inserted. Yes, that may happen.
Okay.
In
So
high
I just
use cases. Yeah.
just want to understand like consistency and durability. So consistency means there will not be change in the data, but durability in the sense like if there is any failure or in there's a server down or anything else, the data should be there. I mean, there should not be any loss, right?
Yes, yes, absolutely. Durability is all about, it is durable. What you say is that it does not breaks, right? Durable. This is very durable. In spite of being used multiple times, it does not breaks.
Okay.
So yes, durability is all about that. If even the system failure is there or you restart the systems,
Mhm.
the data should be there.
Okay. And one thing I just want to understand, as you talked about isolation, you said let's suppose A is transferring to B and B is transferring to A at the same time. So there should not be like any influence. So what will happen next? Just want to understand on this in case of isolation.
Yes, see, in isolation, there could be this account. Assume, no, in the B's account, many operations are happening at the same time. Yes.
Mhm.
So, in multi-threaded application, there could be possibility that you get inconsistent results.
Mhm. Yeah.
Same thing can happen here, but it's another way of saying that isolation is another way of saying that concurrency will be taken care of by the database.
Okay.
Concurrent updates, concurrent deletion, or anything which is happening concurrently, this will be taken care, and there will be
Okay.
no side effects.
Okay. So you're saying that it's kind of synchronization how we have in Java.
Yes, it will take care of
Locking that.
multi-threading, synchronization. Yes, absolutely. Yes, you got it.
Okay.
Yes, because that is important, because you have large number of users accessing, reading, writing into the database.
Okay. Thank you.
Tarun, I still didn't understand this concept, consistency and durability in the concept point of view as well. We can take this offline. Yeah, sure.
Sure. Right. We will be revising also all these concepts. You will understand. Don't worry. But yes, consistency. Okay, let me write it down also so that people understand this, and they will be able to.
I mean, I understood the concepts, but when coming to the SQL and NoSQL, why the NoSQL, if the NoSQL database doesn't support the consistency, then like.
Yeah, NoSQL we are not discussing right now.
Yeah,
When I will discuss, you will get that. Yes.
Okay, sure.
Hold on. Probably next week we will be discussing it.
Sure.
The
Yes.
transactions, when we'll be discussing that, and you told that transactions is part actually, which is actually very much like continued part of this, right? So when will we be discussing the transactions?
Yes, we will be discussing transactions in many system design problems. So when we'll be discussing when we will be discussing system design of payment gateways, in that definitely we'll be discussing that transaction. In various use cases, we will also be discussing system design of e-commerce platform. In that we will be discussing transactions.
Okay.
Yes. So you will get good an amount of coverage of transactions. Yeah, but yes, let me just clean this up so that I can give you the definitions of these 4 concepts, because yes, this you should be aware of for relational databases for any system design interview is very must. Yes. Clear?
Yes, yeah, thank you.
So we are now almost done with the content of today's class. Shall we continue databases for the next class also? Or you want to learn? I have 2 options. We can continue on databases, cover NoSQL databases, fundamentals only. We will cover different types of databases and when to use what. And we can cover more details about SQL. Or we can switch to low-level design and design patterns, and then come back after that to the databases.
I guess it's better that we continue the database. I mean, I'm not sure.
Yeah.
Yes.
Even I agree.
Yeah, because we'll get to know at least completely, and we also get to know like when to choose what.
Correct,
And yeah, that will be actually better. Like we'll have the knowledge about NoSQL and SQL, right? So it will be easy to like it. I mean, at least in designing part, like there will not be any doubt or confusion.
Correct.
Yeah.
I mean that class diagrams also and the sharding part which we discussed the last time. So if these things can be completed, then this complete unit can be completed.
Yes. But yes, before moving to sharding, we have to cover a lot of other concepts, because we can go in depth into indexes. We can go into various data types. We can go into procedures, triggers, how to implement security in databases, how to implement replication in databases, how to do query optimization, performance tuning, right? So there are a lot of topics. Let me list down also that which we'll be covering. Yes. So we will be covering about SQL. It's important. SQL is, that means inserting basically you have to create tables. You have to insert data into the table. You have to retrieve data and delete, update. Yes. So all this, how to do using SQL queries. You have the concepts of joins, because that's important. Then we have the concept of index,
Union.
various kinds of index. Yeah, pardon, you are saying something?
Union. Joins union.
Yeah, union, joins. Right, so. Right, subqueries, a lot of things are there. We'll cover advanced SQL queries. So we covered the concept of schemas also. Then we can cover data types. We can cover about views. We can cover about functions in database, procedures and function. These are also called stored procedures.
Yeah,
Yeah.
I think if you're talking about stored procedure, that means we have to have view.
Yes, yes. There is something called triggers. There's
Trigger.
something called sequences.
Yeah.
Right. So there is, then we can talk about security. That means users, groups, roles. Then we can talk about replication. That means master slave, right? Master replication, multi-master if you have. There are these two configurations which we have. Then we talk about indexes, and then with indexes, performance tuning. Right, so how to make the queries faster by doing performance tuning, how to monitor performance. Yes, so we can do some practicals also, because see, these concepts are highly practical topics. So we can, we should play around with databases. Yes, so I can show you these things online also. So we will use some cloud environment where we can try out all these things. So here we also will cover about backups and recovery, right? So backup and recovery conceptually we'll cover.
These are for
Yes,
all
these are the
this.
topics for database, relational databases.
Okay. For relational, the replication is for both SQL and NoSQL, right? Why it come under SQL only?
I have not listed out for NoSQL.
Yeah, but what I mean is like
It is coming in SQL.
Yeah, it's coming in SQL. It is also coming for NoSQL. So like once the SQL and NoSQL comes, the common part can be discussed later, right? So that's
Yes, absolutely, absolutely. Yes. So understand it from SQL. NoSQL you will understand automatically. Yes. Replication is copying the data, so mostly it is same. Yes, in all the databases.
So like one question here, like replication is a database features, and like even Oracle nowadays it is coming with Hexa CC, cloud based. So means what interviewer will expect from us in the interview? Like we should know the
Yeah,
concept
you don't
only.
need to go to that depth. Yes. So just understand the fundamentals. See,
Okay.
all these things I can go in any depth, right? Entire, it is one semester course, database management system.
Correct. That's a
So yes, if you have to go in depth, it may take multiple months. but we will cover the aspects which you should understand for system design interview. What all we covered, this will be used in low level and high level design interviews. And also all this stuff which we'll be covering, you will be helpful for you to clear the system design interviews. But yes, more depth if you have to go, you can choose what is your interesting area, because in everything you cannot go in depth.
Correct.
So, but yes, you can choose something and do a project related to it so that you get good understanding, and slowly, gradually, you can kind of keep building this specialization in multiple topics.
Basically, in terms of system design, we have to know. like,
Yes,
what-
yes,
that's
but
what we
yes,
know.
primary aim for everyone, clear the system design interview. Then you can explore this, because you will be working with all these technologies day in, day out. Yes. But our
Okay.
WhatsApp group will remain. We will always be in touch. So you can always get the specialization in whatever you need. I am there to help you out all the time. So no worries in this. So yes, but yes, primary first, clear the system design interviews and get into some good big companies. That is our goal. That's the primary goal.
Yeah, Tarun.
Because
Just
yes, you have to answer and explain everything in 1 hour to the interviewer. So you have to be also selective in what to share, what not to share. So that's why I'm also not sharing unnecessary details to you. I'm sharing only the details which you should respond while answering any question in system design interview. Yes.
okay, just maybe not relevant to this, but there is a S3 storage also is there, right? Object storage.
Files.
So
That's cloud storage. S3 is blob storage. Yes. This is binary large object. Blob stands for binary large object. That means that's simply files. Files means it could be text files, it could be images, it could be videos, it could be anything, right? So that's what is S3 cloud storage. We'll cover that also in
okay.
when we will be covering system design of cloud storage. We'll be covering Google Docs, OneDrive, etc. So in a lot of places, the blob storage will come into picture.
All right. Thank you, Tarun.
Thank you, Tarun. And today, actually, it was really great, like to understand indexing at least, which I was like got in depth knowledge, and also like acid properties, which you have actually covered.
Sure. Awesome. Great. Yes. So we'll be anyway covering more in depth about indexes. You will see this in practical examples also. So yes, you will get in depth understanding about indexing.
Arun, what about normalization rules?
Normalization. Yes, this is good point. Normalization rules also we should cover. Yes. Not in depth. See, in system design, in low level design, first 3 normalization we will need. So first, second, yeah, let's cover normalization also. Yes, but yes, this will cover when we will do the design of book my show, or yeah, some system design IRCTC will cover with this, rather than just because it's not required to understand any of these. But yes, I'll cover that. But yes, we'll cover it with normalization, with system designs, with some system design problem.
Tarun, if you think, I mean, the topics which we are telling pushes the timeline, you can also, I mean, if there are some documents that we can go through, if you can
Yes.
send that in the WhatsApp also, then we'll
Yes.
maybe go through it. If this pushes the timeline, then yeah, that needs to be considered, right? Yeah.
Right. Yes. See, yeah, definitely do that. We'll do that. We will be covering up, but yes, understand initially you will see that the pace is slow, but later it will be faster because fundamental foundation are very important. Here we should focus on getting the concepts right. And once you get the concepts right, you can move fast from there onwards. So that is what we will be doing. So today it was all conceptual class, but yes, we did understood some practical examples. But yes, I saw that this was a good suggestion, normalization. I was planning to cover, but yes, we can touch base this also. So keep sharing your feedback inputs also. If you are finding something good, thanks for sharing, and I feel good about that. But yeah, if you share some bad feedback, this way I will take it as a gift for me so that I can improve and I can get better in the next classes. So do feel free to share. Some explanation is not up to mark because yes, I understand it's very complex topic, and learning system design is also a very challenging thing, and teaching system design is even bigger challenge, right? So yes, you need a lot of practical experience. And yes, I have gone through many decades of experience, almost 2 decades of experience working in big product companies, and I have myself cleared multiple system design interviews in Google, in Microsoft, in various startups. So I have also architected various systems. So yes, the way I'm covering, just take it as a guidance, and the same granularity, if you convey, you can clear up to director level. So I'm covering, considering that you will be applying from fresher level to up to director level position. Even beyond that, that's not required, right? If you are applying for other positions, then definitely no system. Yes, so you will get understanding of system design to whatever extent you need. Yes. So yes, but yes, I would need your help. So participate frequently and keep sharing the feedback. I will adapt to that, whichever is working best, because my goal is not to cover all the topic. My goal is to make you all clear system design interviews and get successful in the job interviews and get real offers. So if you are not feeling confident for clearing an interview, just let me know. But yes, you will not become expert in all these topics so that you can implement it, because practical knowledge is another level. It will come with years of experience. But what you should get is good understanding to clear and get into Google, Microsoft, Facebook, Amazon, or any big company, whichever is your dream company. You should be able to clear that interview. That is what I can guarantee in 2 months of time. But yes, I can't guarantee that you will become an expert in all these technologies, because that will need more time. But yes, this is good starting point to first get hired into any big company. Then definitely in that company, when you will be working with top talents, you will automatically become expert in whatever you are doing. Great. So just give me also percentage of how much you understood in today's class. And then we will see you next class with more topics on databases. Great.
Sir, one request from my side. Oh, we understood about distributed technology, and can you show us any real-time environment, how the components are configured?
On the distributed computing. Okay. Okay.
Yeah.
Sure. I'll show you. See, you already know. Whatever systems which we see are all distributed systems. For example, YouTube, Google search, Gmail, Google Docs, all are distributed system. But yes, I'll share you some examples. We will help you in understanding that.
Thank you, sir.
Great. But yes, feel free to ask any questions. It could be fundamental questions because each and every fundamental question is very important. It may come in any interview. Yes. Great. So yes, anyone wanted to discuss anything which is outside the content which we covered so far?
Yeah, Tarun, I have one doubt. This might be dumped out, but I'll ask it. We have a server, and I spinned up a server on one port, let's say 80, and I can also spin up the server on another port, right? Same server on another port, like let's say 85, and same server I spinned up on 90 or something. So, like, if we do this way, why we need multiple instances? In one instance, in different ports, we can do that, right?
Yes. See, this is as per the protocol, network protocol. So here, to any for any service. Yes. Am I audible?
Yeah.
Okay, sure. Because yes, I just got a pop-up saying that the internet connection is not stable. But yes, now if you are able to hear me, that's good. So endpoint is nothing, is a combination of two things, which is host name and port. Port is nothing, is not a physical port. This is a logical address. It's nothing. Logical port. Real port are the port which you put wires into. But yes, this 8080 is not a real port. It's a logical port. That means there is no such slot in the computer or hardware. Yes. So you have to give the host name in case you have local host. This is your host name. And you have to give this differently. Say 80, 81, or you can use different if you have to have different endpoints, different servers, right? So a particular instance will be listening in one combination. One instance cannot listen in all the ports. Yeah, but now this is a good question. Why a same instance cannot listen in multiple ports?
I couldn't able to hear your voice.
But yes, yeah, is that your question? Why the same instance cannot listen to multiple ports, right?
Yeah.
So generally you have only one port because you would like to use multiple ports for multiple services. Yes. So that is the reason. And then you can always do port translation. Yes. We'll cover this in when we will be covering containers and all, that there we'll be covering that. Yes, port is just logical number for routing. You may always map one port. You can export some port to outside world, but yeah, internally you can always route the request to some other port. Yes. So maybe say when the request is coming to some other port, say like 9080, internally there may be one other server which could be a proxy server which can route it to some other port. Yes. Or it may take multiple requests from different ports and route it to some port. That's also possible. Say it may take something different ports and still route it to 8080. So this is some proxy server you may have. That's also possible. Yeah, but yes, you use one server listening to one port. Reason is because you would like to use the other ports because you would like to run so many services. If you start listening, definitely you cannot listen to the same port where some other person is listening. When some other process is listening. Because who has to respond, then you will not know. Yes, so this is as per TCP/IP protocol. This is designed as per TCP/IP protocol. So clear?
So you mean like the other ports will be used for other services? What if
Yes.
there is only one service in a server, and can we use in that case? Ideally, the servers contains only one service, right? Application servers.
Yes, but then in the same machine, you will have so many other services running. Yes.
Yeah, but what if I find a free port? Can I use that?
Yes, you can use the free port. Yes. There's no advantage in using multiple ports. Whether you listen to 10 different ports or single port, there's no such advantage. So better listen to one port only. Because these are not real sockets in the hardware. They are just logical number. They are like variables, right? So you just get some information in this particular port. So there is no advantage of having the information coming in multiple ports. So that's why you always listen to single port. A service will only support one port. Better keep the ports vacant so that in case later you need it, you may use it for some other service. Right? Maybe today you are running only one service, but yes, in future, if you want to run more, you have the option available, right? So that's the advantage.
Okay. And in case of this primary and secondary key, if I have to delete something from the main table, then this without deleting the go to that primary and secondary key. I will take that example.
Yes, we'll cover that in the this called cascading deletes.
Okay. Sure then.
Yeah, so that topic cascading deletes will be covering later in the classes. Okay. So that cover it.
Thank you.
Awesome. Great. I see good number of people, and today only thing is try to also tell your colleagues to join the classes, because I see only 20 people, but yeah, I believe around 60 people plus would be registered. So if we get good participation, then this will definitely increase the experience for all of us, right? Because you can always view the recording, but you cannot clarify your doubts live in the session. And always you will get good learning in the interactive sessions rather than in the recordings. So wish you all the best, and see you in the next class, and have a nice evening.